Thank you. It's 4 o'clock. It's a very good sign, I think, that this room fills so quickly and so early on already. So, Michael, I will not hold you up. Please go ahead with application security and sandboxing.
Well, thank you. I must say I'm very surprised that this room is so full. So that means there are or many systemd lovers or many haters. So I see some crosses, so that's good. A little bit about me. Well, some people already know me. I was active for this organization in different kind of roles. Now as a speaker, I'm also a webmaster. But besides that, I love to do some volunteering tasks, blogging about Linux security. And, well, Linux, Unix, and the combination of security is what drives me. And systemd is something that, well, was something I did before as a cross as well. I didn't really like it when it was first introduced. But I must say, after a while, and especially when really researching it, I started to like a few things about it. So then you start to research, and you find out that there's more to it, and that's something I like to share today. If you would like to read more about my past, I got my personal website, and I'm available on Mastodon. And I would like to invite you all to share and like what you find today. So feel free to make screenshots. And also the presentation will be online as well. So you can read back later on. If you have a question, if it's short, raise your hand. Then we do a quick one in between. If it's a longer one or really an example, let's do it at the end. The slides will be available, and feel free to tag me or the organization if you put something on Mastodon. This talk, the main focus is getting applications more secure by using the Linux security features from the kernel itself and what systemd is offering. Some people here are system administrator, others are software developer, and for all, I think it's a useful piece of knowledge to know what systemd can offer, and use it in your work activities. If you have some feedback later on or questions related to your situation, then we can do that at the end as well. My goal of this talk is also to learn from your experiences. Maybe some already tested out with unit settings and some properties, and maybe failed or maybe succeeded. And I love to learn from your situation and experiences as well. Well, as usual, you start with a big problem, and as the author of the Linux security tool, I got a pull request one day, and someone created a piece of code, and that took the output of systemd analyze with the security parameter, and it results in this output. Anyone already used this command before? Okay. If you run this on your system and you use a Linux distribution that's using systemd most nowadays, or at least the most common ones, then probably you will get the same kind of result. So a lot of unsaves and one OK or 2 OKs. with the nice smileys. So Leonard put in the smileys as well for us, Leonard Puttering. Yeah, and that's an interesting one, because why do you get this output of a default installation? Because I didn't really change anything on my system, and this was yeah, the result already. So the thing is, well, what can we do about this? And this is also one of the questions that users of the Linux tool asked me, or asked in general. Well, it's nice that it gives all these scores, but unsafe sounds unsafe. So, yeah, how can I resolve that? And then typically you want to look at, yeah, what can you do to make any application more secure? And first of all is applying patches from the vendor of the software. So just running your system updates. Then the application developer and you as a system administrator can use same defaults. So don't open up things unless it's really needed. And you can also, depending on the software itself, implement yeah, measures that are part of the software itself, change your configuration and harden up a few things that way. Besides that, you have also the barriers provided by the operating system. And one of those is the file system, so also using same file system permissions. So, well, not the chmod 777, obviously. And yeah, trying to tighten down and yeah, changing the ownership of files in the best possible way. Besides that, you have some security frameworks, and that's something we will talk about as well. And obviously, this talk is mostly about the sandboxing features that well, is provided by the Linux kernel and systemd. So these are the things that you generally can do to make an application more secure. The Linux kernel itself provides modules, well, different kind of modules like drivers, but it also provides security modules, and well, some are more known yeah, than others. Like SMAC is something that is not really that known, but I guess AppArmor and SELinux are more familiar, yeah, to you. Anyone implementing it or using it in their work or at home? So, okay. Namespaces, is that a familiar term? Okay, I see lots of nodding, that's good. Control groups, okay. And secure computing, a little bit less, but still I see some nodding, that's good. Well, AppArmor and SELinux are the most common ones, the security frameworks to well, tighten application a little bit more down. And generally within a distribution, yeah, you have predefined profiles, and obviously you can harden things yourself. In general, AppArmor is a little bit easier for beginners to use than SELinux. And yeah, I put it in the small letters as well. There are many talks about SELinux, especially to make it more well, easier to learn about it. I think both are great as long as you, yeah, understand them correctly and apply them in a good way. But I think AppArmor is easier to understand if you are a beginner, and SELinux is more advanced, especially if you have, well, many systems and can make them more yeah, equal to each other. Well, namespaces. Anyone never heard about it? Okay. A namespace is an alternative reality within the system itself. So you can fake like a process that's running and it can only see or itself or another process, while at the same time there are still maybe 100 processors running. So you can, let's call it a bubble for that process or that set of processes. And we can apply this to processes, but also to mount points, parts of the file system, even the time, the available users on the system. So you can even have, normally you have only one bit with ID 1, but with namespaces you can have multiple ones thinking that they are bit 1. While on the host system, there can only be 1. So yeah, you get tricked into an alternative reality. So namespaces are an important part, especially if you want to sandbox, because you can bubble up things. Control groups, less interesting for sandboxing purposes, but still useful if you want to control resources. So limit things, give them less resources, like CPU or processor time. You can do some accounting with it, which can be useful. And you can even control processes with it. So not really useful for sandboxing in itself, but useful for also creating that bubble and making sure that the right set of processes get the right amount of resources. Any questions in the meantime so far? Everything clear? Yes? The next step, and that's a very important one, is seccomp. Seccomp is there are actually 2 seccomps, so that's why I put them here. It stands for Secure Computing, and it has a set of rules specific to system calls. So each time when a process wants to do something like opening a file, it has some, in the source code it has, for example, fopen to open a file, and the glib within Linux links that to a system call, and that system call says, I want to open a file and I need something from you, dear kernel. And these system calls, they are important, obviously, to achieve the functions of the process. The beauty of seccomp is that it's really binary. You are allowed to do something, and if not, it will shoot you down. It will shoot it down. So if a process is allowed to do an fopen, that's fine. But if it's not, if the fopen is not on the allowed list, then the process will be terminated immediately. So obviously that does not mean that it's getting terminated in a very hard way, that the kernel is not able to close it in a normal way. But for example, it might segfault it, or it might send it a terminate command so that the process will stop. So for the process, it's an abrupt ending, and for the kernel, obviously, it's a controlled way, because you don't want to, kill the system or end up with all kind of zombie processes. So this is very great for sandboxing.
Is that way that that the process gets killed? Can you configure that? Like you said, either it segfaults or it gets a graceful kill, or?
So the question for the camera as well is, are there ways to configure it, or are there multiple ways? Is this, the termination signal always the same? Typically it is the same, but there are a few things within seccomp that you can tune it a little bit. But in the end, it's a termination. when applied, for example, with systemd, typically you will see that it's always the same with just a seccomp or process ending. With regards to seccomp, there are two alternatives. Seccomp was first, and the BPF version was later introduced. They have a slightly different implementation. The one is not better than the other, but it's a slightly different implementation with new insights. And depending on the type of application, and I've put some examples like Flatpak and Snap for application containers. Well, they use seccomp. Systemd does use that as well. But for example, OpenSSH is using the second version with the Berkeley packet filter rules applied to it. So it's within the source code, the developer adds the support for seccomp. So they create it. It's not something like you as a system administrator can put onto it yourself. The system administrator or the developer of the software creates it during development, and then the system administrator they just have a piece of software with the support for it. So sandboxing is great because you can really limit what an application can do and what kind of resources it can access or not. And it's especially within web browsers because they have a very interesting attack surface. Nowadays we do almost everything within a web browser. So you want a piece of software like that, which typically has even more lines of code than the Linux kernel with all the kinds of modules and support it has. You want to really harden things within the web browser. So Chrome and Firefox, they all use sandboxing as well. And typically they build their own set to reduce the possible vulnerabilities and the exploitation, the impact when a vulnerability is abused. Obviously, a security-minded tool like OpenSSH, which is also a very interesting target, they applied it as well. But besides that, I added some examples, sandboxing tools. This is something that you can use as a system administrator where you just say, well, I want to run some tool, like let's say LibreOffice, and I want to do that in a sort of container in the sandbox. Then you can do that with, for example, FireGL and Bubble Wrap. So that's sandboxing, but then in a way that you, as the system administrator, can control. But more importantly, systemd can offer us this as well. And this is what I want to talk about today in particular. So systemd is using seccomp, and with that together they can tighten up things a lot. And the most interesting part is of the service units where it applies to. If we look at systemd itself, I guess we all know what systemd is, but there are two main parts of it. One is it's a system manager, so it controls how things are started, the system itself, but also if it needs to react. For example, if I press on my power button now, then in the end systemd is something doing with it, and probably it decides to put the system in sleep or to power it off. So that's the system manager part of systemd. But the other interesting part is the services manager, and that's how processes are started, but also when a mount point, for example, becomes available, and really the chain of dependencies and when to start up things and what makes the most sense. When it comes to systemd, most people are familiar with the file name ending with .service, but there are more units. Within this list, do we recognize some others, like timer? Did we ever see timer? Yeah. The mount, I guess that's a very familiar one. Okay. Path. Okay. Path is to monitor a mount point or a path and to respond to it. So systemd has different types of units. For this presentation, obviously, we are most interested in the service type. And the reason for that is that's where a process is, started and running for some time. When it comes to systemd and services, we use systemctl to do something with it. So we can start it, we can stop it, we can restart it, we can reload it. We can enable, disable, or really disable or enable it in a hard way, so mask it or unmask it to make it available again. Then we can see the configuration of a service file, so you don't have to cut the file itself, the service file, but you can say systemctl cut and then the service name. And then it will show you the configuration file, but also where it's located. With edit, we can change that, or at least make some changes to it. And then in the end, systemctl status, we can see how it's running, is it running, and are there some specifics. Journalctl, I guess we are familiar with that mostly as well then, to see the logging entries of the system. Any questions so far? No? If you want to learn more about systemctl and journalctl, I created a cheat sheet on my Linux audit blog. As my learning experience as well. In the past, I just knew, start and stop and enable, disable, and then, that was mostly part of the system administration task. But there are definitely a few tricks. So if you are interested, look up the slides, and I put in the links to some of the cheat sheets and the overviews. Well, when it comes to hardening and using sandboxing features of systemd, we need to make changes to the configuration. So a vendor typically provides a file, a service file, and the vendor is not the software developer usually, but for example, the package maintainer. They create a vendor-supplied initial configuration, so that when you install Nginx, for example, the package maintainer provides a service file to make sure that if you say, systemctl start Nginx, that file is used and that, it knows where to find what, the binary itself, paths for logging, where it can store its PID file, what it should do when the process abrupts or quits or stops suddenly. So we can see that initial configuration with the cat command. When using the edit command, we can change or the vendor-supplied file, but usually you don't want to change that because it can be overwritten when you update your package. So you want to edit it in a way that it creates an override file. So the override file will extend the vendor-supplied initial configuration. So this way you don't overwrite the files itself, but you extend upon the basic configuration. If you are doing configuration management and using something like Puppet or Ansible or Chef or Salt, then usually you don't want to use these commands, but you can create a file in the one of the two paths at the bottom. And it depends, obviously, if you want to automate things. So normally, if you use the edit command, you see an override file, the override.conf. You can make or use another name, but this is what is used by default. And you see that it's showing command lines, and you put your configuration into that. So then it looks something like this, where you can say, well, I want to make some changes to the process. It needs to be running more relaxed than it already did, so you give it a nice value or something else. So this is the basic way to make changes. Well, when we look then at the actual hardening, we come to the properties, and protect system is one of them. Very powerful, marks parts of the file system as read-only, so you can really tighten up things very quickly. But yeah, there are many of these kind of properties, and how do you know, well, which ones that you can use and where you can find them? And that's also the biggest challenge. There are at least 40 of them. Most of them are available for sandboxing functionality. They are documented, and most likely a die-hard, seasoned Linux person will say, well, it's there. But as a beginner, and especially if you do this for the first time, you see one big, long list of things, and the documentation is something, it's not beginner-friendly. It lacks examples, and it has many exclusions. So if you use this and that together, you should be aware that it also may impact that other thing. So there are caveats all over the place. This is not readable, but this is just an example of a beginning of this one big online documentation, and it goes for many pages. So you can definitely find that property. So what I've done is I created a list myself on my blog to pick out those things that are useful for sandboxing, and document them, and also edit a version number, the initial systemd version, when it was made available. The nice thing of systemd is when you use a property that is not available in your systemd version, so on your system, when it does not recognize it, it will just simply ignore it. So you can really create nice templates, just apply them, and if it finds something that it's not knowing, then it simply ignores it, and it will still apply those things that are applicable to it. So I've created a few documents, because just doing the troubleshooting alone can be a presentation in itself, so I want to avoid that part. So I would suggest if you are interested in the topic, definitely look at the slide deck and click on the links to see the type of unit settings that are available, but also how you can apply them and how you can troubleshoot them. So one of the things that I also did was starting with creating hardening profiles, because it's nice if you're running Nginx and you have to do the same type of work as all other people here. So I started by creating a hardening profile, so a predefined set of settings that I think that are great as a starting point, including the settings itself, and also with the links where you can find more information about it. And when you start using it, especially the first time, obviously you can just copy-paste a hardening profile and see if it works. But that's also the nice thing about systemd. If you apply these things, you will definitely get the most beautiful errors that you have seen, and probably not seen before, because things will crash or they will stop working very quickly. And that's not a bad thing in itself. That's not the fault of systemd. It's simply because if you apply, 20 or 30 settings at once, that most likely you will come across something that was not available, for example, on my system. And then you will see something at the bottom. So if you say, I restart Nginx, then it will say, it stopped with an error code. And then it gives you a hint, check the status to see why that is. Well, then you get this nice kind of output. Red obviously is bad. And it shows you then a line saying, failed to execute, Nginx, permission denied, failed at step exec spawning, permission denied. So that doesn't still say, the reason. It only says, something went wrong with the permissions. And that's the big challenge in these kind of things. Why it failed. Typically, you would think, maybe it has not the right file system permissions or something like that. But sometimes it's not that obvious, and that's in this case. Nginx is, it depends on libraries, and that are also executable pieces of code. So if you just only say, I want to allow the exec paths, but nothing more than that, and it wants to read something from the user lib directory, it will fail as well. So you really need to apply things step by step and very carefully. Now, that's also one of the most important tips I would give you or want to share with you. If you start applying these properties, add just first, let's say 1, 2, or 3, but not apply 5 or more at the same time. Because if it fails, then you have to deduct by removing them all again. So it's better to add a few, see if the process is still working, restart it a few times, see if it can still create log files. And obviously use the status command to see if it's running correctly. Sometimes the process might be running, so you might think that everything is okay. But if you, for example, do a HTTP request, then it might still fail. Or maybe a child process might fail. Do it in small steps, and especially look in the status output and check out the journal CTL as well, because it might prevent, or it might show you some interesting hints which might prevent execution or execution of its child processes. Especially with capabilities, so these are the Linux capabilities and the system calls that you can apply or, restrict or allow for a process. These are the most tricky ones, because typically the developer of the software, they know what kind of functions they need to have a working program. But you as a system administrator, typically you run the program and you simply want to use it. So that's a more tricky part to tighten up, but it's actually also one of the most important parts. For that you can use LDD and the strace command to see what kind of libraries are linked. But also what kind of system calls are being used by a program or a process in this case. Systemd has also an interesting feature, and that's also a property. That's a system call log. So that's actually the same as restricting normally the system calls, so the list of system calls that are allowed. But instead, it just logs them. So it's sort of a try out, dry run function to see, well, if I would restrict this, what would go wrong or what would succeed.
So aren't you worried about stuff that works and then after 2 weeks breaks or stuff like that?
Yeah, so the question is if you harden things and it starts initially and everything looks good and you continue, what could happen in the longer term? Typically you will see if it's too strict that it fails directly. So you get that nice, amazing error message that you've never seen before, because it's really related to the hardening that you do. So if specific system calls are not allowed, there's a big chance that it already was used before. The chance that it really takes 2 weeks to show up is very small. So if you start hardening, especially you want to try it first out on test systems and then slowly deploy it, and that it's really a delayed failure. I've not seen it before, but obviously it can happen, especially with let's say bigger applications that have, for example, a cleanup task, something that is executed by the program, by the process, and let's say it's not running within a day, but just once a week, then you might see something like that. But especially for those bigger applications, you want to take a little bit more time to troubleshoot, or at least to monitor and then troubleshoot. So my goal also in sharing this is to show you what I've done on the Linux audit blog, which is, well, obviously open source and available for everyone to learn from. The idea is to create as many hardening profiles for the applications that you and I are using. So that might be Apache, Nginx, database engines, any application that you see, well, is common for your environment. I see, for example, a proxy on his shirt. Any application that you're running and that you say, well, this might really benefit from being hardened, and that we can create a hardening profile for. Reach out and let me know, because then we can check out what we can create something together. Obviously share what's useful for you and your systems, because this can apply, because it's service units. So this applies obviously to servers that are running applications with the relevant service units. But it also applies to a desktop, for example, your Bluetooth service that's running in the background, or a wireless application. So anything that's useful.
I was wondering if you make such a hardening profile, do you ever send it back to the package maintainer if it is an improvement, or is it too system specific or anything, or do you have other reasons not to do it?
Yeah, so the question is, if we create a hardening profile, do we then submit it upstream to or the application or a package developer or someone else? Well, that's a very good point, because that's a very tricky one, because there are a few initiatives, but none of them is really making some traction now. Because obviously we would benefit if it's the default. So if you, well, let's say, install Debian, and the Debian project and the package maintainer already provided a hardened service instead of just a generic one, But they say, well, yeah, we cannot do that because we don't know what you exactly are going to run within your Apache or Nginx installation. Then you have obviously the software developer, let's say Nginx. They don't create it because they say, yeah, but our application is running on many different distributions. The paths are not always the same. We don't know exactly what you're going to run, so we just want to keep it open. So, for example, within the Fedora project, there's an initiative for this as well, to try to provide these things upstream as possible, or, well, send them upstream and get them applied for as many people as possible. But you see the same kind of reasons that they are rejected, with a few exceptions, where they say, okay, this is a very generic, safe thing that we can do. They don't apply then all 40 properties, but just a few that they say, well, these are generic, safe. For example, that a normal process should not be able to change the host name. Then they say, well, okay, this will not affect us. But a project like Docker, they also said, well, we are not going to implement this upstream because containers and the way, the kind of permissions that it's required, if we would already harden them upfront, then things are not going to run. Users will complain and they don't know how to troubleshoot this. So that's why it's so important that we as system administrators, that we need to apply them as much as possible by ourselves. And where possible, we can then test them out and in the end try to submit them upstream. So I would be really open to do that, but as for this time, I just try to make the knowledge available as much as possible, especially with the remark of the systemd documentation, for example, being not that beginner friendly. So we need some point that we at least understand how it works, how you can step by step find out which properties there are, apply them, and then in the end, if enough people run it, then we can create some issues with the package maintainer or the software developer itself and say, hey, this is what we have, it looks stable, can you consider at least implementing it? Question in the back?
It looks to me like most of this pertains to system units. How much of it is applicable and useful for user units? Those are on a second level.
So the initial part of the question is, you say it's applicable to system services.
Yeah.
And the last part?
How much of it is applicable for user services?
User services. And you mean a user service within systemd itself, or just generic you as a user running a service?
For systemd.
For systemd. It's in fact, it's the same. So you can apply them to both. It does not really make a big difference. Initially, you want to harden those kind of processes with the most risk of being exploited, for example. So especially something like Nginx or Apache, which is listening to the internet or available on the internet. You might benefit from those the most. And the systemd user services, typically you run on your own service or on your own system. They have a lower risk.
We only have 1 minute left, actually. So Edwin just signaled me. I will give him the microphone.
And that's the last question then, I guess, as well. Okay.
I'll make it quick, hopefully. Thanks for this talk. You showed us the output of systemd analyze security before you did any hardening. What is the expectation we would see if you run it again now? Yeah. How many unsafes are still left?
Well, that's the tricky one, and then a very good question. Because many services, they, for example, require the network to be up and available. So some services you will never be able to really make from unsafe back to safe, but you can at least increase the score. On the other hand, a service like Nginx, which typically also normally has, everything is open, there you can really improve it a lot. Obviously, you cannot remove the network access from it, but you can say, well, Nginx should not be able to change the time of the system or not the host name of the system. And there you can score a lot of points as well, but also restrict what it can access on the system itself. So the ones that you saw, many you will adjust slightly, and at the same time, others you can really improve a lot. So it depends really on the service itself. Yeah.
Thank you, Michael.
Perfect timing. Thank you. I will be available here, so if you have any other questions, please see me.